Hey guys! Well, it's the next video, and I promised drop problems. Now we're going to start solving these on the board. We'll see how to solve them, but the real goal of drop problems is to be able to do them all in your head. You're taking physics because you want to end up smarter than you were before. One of the ways you become seriously smarter than you were before is by doing drop problems and doing them in your head. I'll show you how. It's not only not too hard, it ends up being fun. And I recommend you challenge each other by just giving a number of seconds and asking how far something would have fallen. Well, here on planet Earth, everything accelerates downward, including your physics calculator, at 10 meters per second every single second, or 10 meters per second squared. Now, the real number is 9.81 meters per second squared. Tell me, would you ever be able to see the difference? No. So it's easy to use 10 meters per second squared, and you're pretty close to exactly right. Now, the numbers, when you use 9.8, will be slightly different, of course, but not very different much at all. So check out how we do drop problems. Think of the logic. At 0 seconds, okay, granted, my velocity is 0 meters per second. My average velocity, how do you find average velocity, right? Well, my average velocity equals my initial velocity plus my final velocity divided by 2. And because my initial velocity in every case is 0, it's just basically taking my final velocity and dividing it in half. That's not too hard, okay? So, my average velocity in this case is still, of course, 0 meters per second. How far have I fallen? Okay, this is easy, 0 meters. But what's my acceleration? Now, be careful. Don't say my acceleration is 0 meters per second squared. If this calculator is accelerating at 0 meters per second squared, 1 second later, it's still where it is. So granted, right now when I'm holding it, yes, its acceleration is 0 meters per second squared. But right now, it's not moving at 0, it's not accelerating at 0 meters per second squared. It's accelerating at 10 meters per second squared. With an acceleration, look where it is now, and then wait 1 second and see. If it's still there, yes, it has 0 acceleration. But if 1 second later, it's in a different spot, it doesn't have a 0 acceleration. Good to know. So my acceleration is 10 meters per second squared. Okay, look, at 1 second, what's my velocity? Well, if I'm changing my velocity by 10 meters per second every single second, and 1 second has gone by, it stands to reason, my velocity now is 10 meters per second. So what's my average velocity? This is key. On this question, a lot of people are going to say, so how far has something fallen when it's fallen for 1 second? And you know the acceleration is 10 meters per second squared, so you're going to go, oh, quick, your brain just gives you the quick answer. It's going to say, oh, it fell 10 meters. No, it didn't. You have to consider your average velocity. So you ended up at 10 meters per second, but you started at 0 meters per second. So what's your average velocity? Right. Your average velocity for that whole time was 5 meters per second. 5 meters per second times 1 second. So the distance you fell is 5 meters. Now, when you use 9.8, it's really 4.9 meters. Who's counting? So your distance you fell is 5 meters. Your acceleration does not change. It's still 10 meters per second squared. Consider 2 seconds. What's my velocity? 20 meters per second. What's my average velocity? I'll give you a second. 20 minus 0, that's 20, divided by 2 seconds. My average velocity is 10 meters per second. And I did it for 2 seconds, so it fell 20 meters. My acceleration is still 10 meters per second squared. Now, you see 20 meters here. A lot of us, because our brain always wants to do the simplest thing, a lot of us are going to say, oh, I see a pattern. At 3 seconds, it's going to fall, it would have fallen 30 meters. Let's see if that works out. 3 seconds, my velocity is now 30 meters per second. What's my average? Well, 30, cut it in half. My average velocity is 15 meters per second, and I did it for 3 seconds. 3 seconds, every one of which I'm going 15 meters, that gives me 45 meters. 4 seconds. All right, my velocity is now 40 meters per second. What's my average velocity? Yeah, you're catching on, 20 meters per second. 20 meters per second for 4 seconds gives me 80 meters. 5 seconds. Now moving at 50 meters per second, average 25 meters per second. 25 meters per second for 5 seconds. Right, 125 meters. You can tell, if you're trying to do these numbers in your head, it's a little challenging. Some find it easier than others, that's fine. But if you find it fairly challenging, this will make you phenomenally smarter quite fast. If you already got this stuff, all right, it's not going to really affect you. So be happy if you find this to be sort of challenging, because it will change more fundamentally how your brain works. And that's what we all want. 6 seconds. We're now moving 60 meters per second. Average is 30 meters per second. 30 meters per second for 6 seconds. Well, 3 times 6 is 18. Put a 0 after it. 180 meters. Oh, meters per second squared. Don't forget the square there. So I'm going to erase this for convenience sake so I can keep moving on. Not going to erase that. That never changes. So we're 7 seconds. Now my velocity is 70 meters per second. What's my average velocity? Half of it, 35 meters per second. What distance? Well, what's 35 times 7? Oh, now we get some challenges. Do it in your head. What's 3 times 7? 21. Put the 0, so it's 210. And then 5 times 7. What's 5 times 7? 35. So 210 and 35, 245 meters. No, not meters per second. 245 meters. All right? 8 seconds, moving at 80 meters per second. Average is 40 meters per second. So 4 times 8, with a 0, 320 meters. 9 seconds, that's 90 meters per second. 45 meters per second is your average velocity. What's 45 times 9? I don't know. What's 45 times 10? Hope you get 450 real quick. Well, you didn't do it 10 times, you only did it 9 times. So what's 450 minus 45? See how easy this is. 405 meters is how far you fell. 10 seconds, your average now is, or not your average, but you're moving now at 100 meters per second. Average is 50 meters per second. 50 meters per second for 10 seconds, you see? 500 meters is how far you fell. Let's go on, 11 seconds. 110 meters per second, 55 meters per second is your average. 55 times 11, I don't know, but 55 times 10, that'd be 550. Add 55 to 550, hey, look at that. 605 meters. You see how to do this? Sometimes you run up against something. Figure out how to work around it, and then just keep on going. How about 12 seconds? The last one we're going to do. 120 meters per second. 60 meters per second is the average. 60 times 12. I don't know. So how about 60 times 10? 60 times 10 is 600. What's 60 times 2? 120. So what's 600 plus 120? 720 meters. Guys, this is how you do drop problems. Practice it, and most especially, practice how to do it in your head. If you go up to 12 seconds, some of this you can memorize, but most of it you're not going to be able to memorize so easily, and who would want to memorize it anyway? Have fun doing these problems in your head. When you see another physics student, tell them drop problem, 5 seconds, and see if they can't come up with 5 seconds. And you do it like this. All right, 5 seconds. Starts at 0 meters per second, ends at, and do your hands, ends at 50 meters per second. Average 25 meters per second. For 5 seconds gives you 125 meters. Bam. Do them in your head. Your starting, your final, your average, times how many seconds you were doing it, there's your answer. There's something about moving your hands around. Those of you playing along at home, move your hands around. Do this. You might look goofy, but you're doing good physics, and it makes you smarter. And the really fun part is, It makes you smarter fast. We like that. Thank you for watching. See you next one.